Hey guys, by request, here's a problem with buoyancy. So a bathysphere, I guess, is a sphere that you put in the bath. I'm kidding. So we have here radius 1.5 meters. Mass of the bathysphere is 1.2 times 10 to the fourth kilograms. All right, so this thing, if it was hollow, would float, I guess. In order to dive, it takes on mass in the form of seawater. I'll say there's some water in there with a mass of water that's unknown. Determine the mass the submarine must take on so it can descend at a constant speed. So constant speed when the resistance force is 1100 newtons upward. So here's what we have. We have really M total G. We have a resistive force and we have a buoyant force. All right, we are assuming right now that this thing is underwater. We want it to descend at a constant speed, which means net force is 0. All right, so we want to find what that mass of water is. That's going to live in here. We're going to say that this is really M water plus M bathysphere times G. Okay? And really you might write it like this, probably most effectively. M water G plus M bathysphere G. If you wanted to draw those as two separate weight vectors, that would be fine. So we'll do this. R plus buoyant force equals M water G plus M bathysphere G. I kind of did the net force equals 0 and then moved these two to that side, to the right, in one step there. So mass of the water, I'll do this, R plus FB minus mass of the bathysphere G equals mass of the water G. And yeah, we'll divide by G. I'll do that in a couple of minutes. Okay, so known. We got to figure out the buoyant force. All right, so by definition, buoyant force is equal to, this is Archimedes' principle, buoyant force is always equal to the weight, I'll do this, weight of the fluid displaced. All right, now you won't write it like that, but we can go from there to here. Well, that's mass of the fluid displaced times G. Well, we've gotten used to the idea of relating mass, volume, and density with rho equals mv. So that means that mass equals rho v. So that means that buoyant force, and here's the form that you use, rho fluid, v fluid displaced, g. Now I haven't written it before as F hyphen D there for displaced, but that's the idea. Rho fluid, V fluid, G. It's always the volume of the fluid that's displaced. All right, and a big deal with that also is that every time V fluid displaced is the same as the volume of the object that's submerged. Right? 7th grade science class, how do you find the volume of the rock? Well, you dunk it in the water and you look at how much fluid or how much water was displaced, right? How much the volume of the water changed. So that's a big deal and one that people have a tough time remembering, to be honest. Okay, so this we're going to put in here for buoyant force. Okay? So I'm going to try to keep this all as one big expression. So we're going to have resistive force plus rho fluid, V fluid G, minus mass of the bathysphere G equals mass of the water, G. All right, now again, known, 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 known. The question is, what's the volume of the fluid displaced? Well, again, it's the volume of the object submerged. Well, in this case, that's the entire sphere. Okay, so we're going to write that rho fluid. This is 4/3 pi r cubed G minus m bathysphere G equals, and here I'll finally divide by G to get mass of the water by itself. Okay? I went to a new page just to reiterate. Buoyant force, by definition, is always rho fluid v fluid G. Okay? And just so, you know, I know on the last page we talked about it, but this is mass of the fluid. So it's mass of the fluid times G. Mg is weight. So again, Archimedes' principle says buoyant force equals weight of displaced fluid. Okay, that's the big deal. Yeah, I think that'll do it. Okay. The one other thing, of course, is that volume of the fluid is really volume of fluid displaced, which is always the same of the volume of the object submerged. Now, real important, this might not always be the whole object. Not always VO total. All right, there are cases for sure where we have surface of the water and a raft of some sort of something like that, where some of it is underwater and some of it isn't. Okay, in this case, whatever. Well, I guess I can do it like this, and that would be this would change a little like that, right? I don't know. So in this case, here is your VO submerged. Right? If this thing floats where it is, with the water at that height, it's because mg equals FB. Right? mg equals FB, or mg equals rho fluid v fluid G. All right? So we could end up doing something like saying, well, again, this is mg equals rho fluid. Now, v fluid is v object submerged. Right? So you wouldn't use the volume of the whole thing. You can only use the volume of the object that's under the surface. All right? There's a question somewhere on the first buoyancy questions we did, the first homework sheet about that, about what percentage of the object is submerged. Well, we could do, this is rho object v object total, right? The whole mass accounts for its weight. Here we go, rho fluid v object submerged times G. We could do, oh, I forgot the G over here on the right. There's a G. We could get rid of these G's. Right, and there's a little expression. If we did volume of the object submerged divided by volume of the object total, well, apparently that's equal to density of the object divided by density of the fluid. All right, so there's a way at least to find a ratio. The ratio of how much of it is underwater is equal to the ratio of the densities. Right, and it says if the object has the same density as the fluid does, say as water does. If this left side is 1, that means that the entire object will be submerged, right? Because the volume of the submerged object and the volume of the total object have to be the same if their densities are the same. So things that are just as dense as water, I think what we called at one point neutrally buoyant. It would just sit underwater and just sit there. All right. All right. So there's a little more than just a solution, but maybe a little extra helpful stuff. That's it. I will put one more up. I'll do some sort of Bernoulli question too. Okay. All right.